Okay, I believe we covered the entirety of the chapter, although we skipped output stream manipulators. And you use stream manipulators when you want to format your output exactly. If you want to set your output to print in columns, for example, you can say, okay, I want this number to print out and I want it to occupy 5 spaces on screen. Or if you're trying to print something but you only want it to print out to 2 degrees of accuracy, like 98.61 rather than 98.61111359, you can limit the precision with a stream manipulator. The stream manipulator that controls the width of the next value to print is set W. So set W controls the width of what you're going to print. And then there's a set precision. Set precision allows you to specify how many places after the decimal point will be printed. So, we're not doing examples of those, although we probably should. Just telling you that it certainly is possible, and if you need to figure out how to do it, Google up stream manipulators or hit the book, and you'll see it. So, onward and upward to the next chapter. Actually, PowerPoint 4 is going into the Unit 2 chapter, Unit 2 folder. And as always, downloading a PowerPoint is far better than trying to view it in our silly little preview window. Making decisions. It's late, so I want you to stay home. That's a decision. Relational operators are used to make decisions. Is something greater than something? Is something less than? Is something greater than or equal to? Is something less than or equal to? So these are relational operators. Relational because they say how one thing relates to another one. And we pretty much know already how they work. It's For one thing, we've all done junior high or grade school math. So you could say things like this. If A is greater than 3, or is A equal to 3, or if A is not equal to 3. That's the only one that wasn't covered in our grade school math. Instead, I think we use greater than, less than, the two angles pointing towards each other. If A is greater than or equal to 3. And then the less than versions. If A is less than 3. Or if A is less than or equal to 3. So you have to be careful when you're trying to figure out whether a value is on one side of the boundary or the other. If you want to do this, if a number is greater than 3, print OK. Otherwise, print not OK. That's easy to do with an if-else, but it might not be immediately obvious that the opposite of greater than 3 is not simply less than 3. It's less than or equal to 3. So doing this one would be easy. If A is greater than 3, then print OK. But if we want to do the opposite, without using an else statement, we would do this. If A is less than or equal to 3. So the opposite of greater than 3 is less than or equal to. And I hope that makes sense, because you have to decide what to do if it is exactly equal to 3. Well, if it's equal to 3, then this clause is not going to be true, so it should not print OK, because it says if the number is greater than 3. And that's why we have to include the less than and the equal in order to make the second half of this OK, if we weren't going to use an else statement. So the opposite of equal is not equal. The opposite of less than is greater than or equal to. The opposite of greater than is less than or equal to. You know, and we could get silly and say, what's the opposite of not equal? That's really enough, right? So when somebody gives you a problem, they need to define whether the values are inclusive or not. And inclusive means whether that number is involved, is valid if it equals that. So somebody could give you a range of values like this. They could say, if the number is between 50 and 90, then print OK. Well, you need to know whether 50 is a valid value and whether 90 is a valid value. Is this range really 50 all the way up to and including 90? Then that would be inclusive. Inclusive means that 50 and 90 are okay. Exclusive means that it has to be greater than 50 and less than 90. So 50 itself would not be okay, but 51 would be. And 89 would be okay, but 90 is not. So a value between 50 and 90 inclusive. You can't do this, although you wish you could. If A is less than 50, if A is greater than 50 and less than 90. That's not valid computer syntax. Or how we worded it in junior high, if 50 less greater than A greater than 90, that's also not valid. The way we have to do this is with an and. We have to say, this is invalid, this is invalid. So we will use the and operator, which is a logical operator, meaning that both sides, both operands are true, and then the result is true, or we use the or operator. And so we write expressions like this. If A is greater than 50 and A is less than 90, then print OK. And I think I was using the and operator without. No, I hadn't actually written the code yet to do that. So that's how you would express that if it was not inclusive. So that would be worded like this. If the number is between 50 and 90 exclusive or not inclusive, then print OK. That's how you would do that. But if you wanted to make it inclusive, then you would just make it greater than, equal to, or less than or equal to. If the number is between 50 and 90 inclusive, meaning that both 50 and 90 are valid values, then you use greater than, equal to. If A is greater than equal to 50 and A is less than equal to 90, then see out OK. Now in these little programs where I say make it print freezing if the temperature is below 32 and make it print boiling if it's above 212 and stuff like that, I'm not real hard about whether these things are inclusive or exclusive. But I should be, because that could actually be a really important thing in programming, determining whether your condition was supposed to be inclusive or exclusive. So along with the and operator, there's the or operator. For and to work, both sides of it have to be true. This condition is not true if one of these is false. It would not print OK if A was not less than 90. So if we said A is equal to 100 and then we try to execute this statement, are both sides of the and true? Is A greater than or equal to 50? Is that true? Somebody pretend you're listening. Yeah, that's true. Well, what about the other side? If it's equal to 100, is it less than or equal to 90? 100 is not less than or equal to 90, so that's false. Yeah. All right, so it would not print OK. And we see why, right? Because if you're using and, it means both of them have to be true. So you can set up a little truth table. The truth table for and looks like this. You have two inputs, and then you have a result. If they are both false, the result is false, because neither one of them is true. If one of them is false and the other side is true, well, our requirement is for both of them to be true, because we use the word and, so that result is still false. If the first side is true but the second side is false, the result is false. The only time and works is when things on both sides of the and operator are true. So if A is true and B is true, we get a true result. And then there's or. If A is less than 50 or if A is greater than 90, print not OK. So if A is less than 50 or A is greater than 90, print not OK. For or to work, only one side or the other has to be true. If they're both true, it's great, but only one of them have to be true. So now let's pretend again that A is equal to 100. Is A less than 50? Okay, so if A is 100, is A greater than 90? Yes. So it's going to print not OK. Because with the or, only one side or the other, or both. It's not mandatory to have both sides open in order for the result to be true. So this is how you check to see if something is within a range. You use and. This is how you check to see if something is outside of a range. What do I mean by that? Because values between 50 and 90, all those values in that range are not going to be captured by this. It's only when values are less than 50 or greater than 90. So use and to check for a range. Use or to check for outside of a range. And we can make a truth table for or. A or B and the result. Well, one or the other or both have to be true for the result to be true. Well, do we have a true here? No. Do we have a true here? No. That means that the answer, the result of A or B is false. What if one of them is true? Well, since it's not an and, either side can be true and the result to be true. So false or true is what? It would be true. Because if one condition is true or if the other condition is true, then the result is true. So if I am sick or I am tired, stay home. If that's true, or if that is true, then the result is true. if A is true and B is false, I am sick but I'm not tired, I'm still going to stay home. And then if they're both true, even better. I am sick and I am tired, I'm going to stay home. But if I am not sick, if A is not true, or I am not tired, B is not true, then I'm not going to get to stay home if I'm neither sick nor tired. So this is the truth table for or, and this is the truth table for and. And sometimes they're expressed as zeros and ones. What did I just do? I just did something very stupid. No, I didn't. That's the truth table for and this is the truth table for or. You can express them just as zeros or ones. A and B, and the result 0 and 0 gives you a result of 0. 0 and 1 gives you a result of 0. 1 and 0 gives you a result of 0. 1 and 1, that's the only time that an and becomes true. How about or? A or B, and then the results. 0 or 0, it's still a 0. Neither side is on. But for or to work, if either one of them is lit up, then the result is true. 1, 0, or 1, the result is 1. 1 or 0, the result is 1. 1 or 1, the result is 1. Notice that the only time an and is true is when both of them are on. All the other cases are false. In contrast, the only time an or is false is one time, when they're both false. All the other conditions are true. So we've covered the two logical operators. We've covered and, we've covered or, and then there's one more. There's not, which is the exclamation mark. And the way not works is if A is true, then not A is false, and vice versa. It just reverses the truthiness of it. If A was true, then not A is false. If A is false, then not A is true. Now that's a real short truth table right there. So that's when you do things like this. If not A less than 3, then C out okay. Now let's plug in a few values. Now let's say A is equal to 4. Is it going to print okay? Work through the logic with me. A is less than 3. Is that true?
A is not less than 3.
Right, but just the part that I've highlighted here, is this true or not? Currently it is not true. So this evaluates to false, but then this turns around and turns it to true, which means it'll print okay. So not logic is a little bit convoluted. It puts knots in your head when you're trying to think about it. Pun only slightly intended. How about if A was equal to 1? So we decided that if it was 4, it would print okay. What if it's 1? Is 1 less than 3? Yeah, it is. So that evaluates to true, but then the exclamation mark turns it into a false, and so it would not print okay. This could easily be rewritten. I tend to rewrite my expressions so that they don't involve knots, because I think the logic is harder for us to wrap our brains around. The better way to write this, in my opinion, would be to say if A is greater than or equal to 3. These mean exactly the same thing. If not A less than 3 is the exact same thing as if A greater than or equal to 3. Those are the same expressions. Just like what we did up here, we said that the opposite of less than was greater than or equal to. And the opposite of greater than is less than or equal to. If we have this expression, if A is greater than or equal to 100, and then I wanted to write that with a not, I could do that. If not A, now I want to reverse this expression. How do I reverse that? I change the greater than to a less than, and I leave the equal sign off. Those two expressions are the equivalent. And again, not kind of hurts my brain, so I only use those when I think it's at when I think it helps. Of the two, I think that this is easier to understand than this. Maybe you like it the other way, and if so, that's okay. So we know the way an if statement works. If it is raining, take an umbrella. If it is cold, wear a coat. We have an if, and then we have something that follows if that condition is true. Is it cold outside? Yes, wear a coat. No, don't do anything. Is it cold outside? Yes, wear a coat, wear a hat, and wear gloves. If we were going to do this, we would need a brace to start our block, and we would need a brace to end our block. If you only have one statement after the if statement, the braces are not necessary, but they don't hurt. If you have more than one statement inside the body of the if statement, then the braces are mandatory. So I could do this. If temperature is less than 32, print, wear a coat. I could leave the braces off, or I could put them on. Both are okay. But if I want to include more than one thing as part of the body of that if statement, I absolutely have to have the braces. And why is that? Because what if I worded it like this? What if I took the braces off? And then I set temperature before we come in here equal to 100 degrees. So it's pretty dang hot. What's going to happen when we execute this code? Well, is our temperature less than 32? It is not less than 32, so it's not going to do that. But since we didn't use braces, it's assuming that this body of the if statement is only one long. And so the rest of these occur whether or not this is true. So if temperature was set to 100, it would tell us to wear a hat, and it would tell us to wear gloves. If we want these to work correctly, we have to put them inside the braces. And it's never wrong to put braces after an if statement, even if you're only doing one thing. Doing this is totally good, but not necessary. But if you have more than one statement, you have to put the braces. So why is it a good idea to put the braces even if there's only one thing? Because that makes it easier to come back and then add more things later. Because if I do this, if I have temperature is less than 32, then print out wear a coat, and then I tell you, oh, and also tell them to wear a hat. I go, okay, I see that. I'm just going to put that there. It's not going to work. This is not valid code. For the same reason we discussed previously. Some languages do everything based on indentation. Python is a language that this would actually work with. But this isn't Python. This is C++. And in C++ and in Java, if you don't put the braces, then only the first thing after the if statement is executed. And by the way, people always want to put semicolons there. Never put a semicolon after an if statement or before a curly brace. What do I mean by that? Well, if I had a semicolon here, it would be the same as this. these three things would happen regardless of whether this was true or false. It would be the same as writing that. If temperature is less than 32, do nothing. Okay, that's cool. If it's less than 32, I'm going to do nothing. If it's not, who cares? And now I'm going to come down here and I'm going to print these three things anyways. So having a semicolon after an if statement completely breaks it. You don't put a semicolon after an if statement. You don't put a semicolon after a while or a for. You do not put a semicolon anywhere where it would occur before a brace if you move that brace up to the same line. That just totally breaks it. This is not valid code. I almost spelled code like this. This is not valid code. Right. It would print wear a hat no matter what the temperature was. Good. So the format of it. If expression statement. This expression needs to be something that evaluates to either true or false. By expression, it could just be a single thing. We could just have the word true there, in which case whatever this was, it would always happen. Or it could be a Boolean variable. We could do this. Bool am hungry is equal to true. And then if we put if am hungry, then do whatever was down there. This is valid. This is a valid expression because it evaluates to either true or false. But more often you see an expression with an equality operator of some kind. If A is greater than 3 or you know, anything like that. So the code shows them doing if the average is greater than 95, print. Just congratulations, that's a great score. If it's not greater than 95, then the code didn't show printing any message out whatsoever. So you did all that hard work, but we don't get a special message. If statement notes, do not put a semicolon after the expression. Place the following statement on a line below the if statement. Be careful if you're testing floats and doubles for equality. We'll get into that later. But since floats and doubles can manifest rounding errors, it's usually not enough just to say if A equals B. Usually you have to check to see if they're close enough to count. Expanding the if statement. Not only are there ifs, okay, sorry, it's going into the wrong lecture. If you want to do more than one thing after the if statement, you enclose that code, that block of code in braces. So not only are there ifs, there are if-elses. If-elses is when you have two things that you want to do, like that. If it's true, you want to do something. If it's not true, you want to do something else. So here's how you check to see if a number is even or not. If you modulus it by 2 and you get 0, you know it's an even number. So if number %2 equals 0, print it's even. Else, print it's odd. So there's effectively three forms of if logic. There's if, and you use if condition, do something. That's the way you think of it. Something. Okay. That's like one form of if logic. The second form of if logic is if else. If condition, do something, else do the other thing. And then the third one is if else if. And that's if you want to pick among 3 or more different actions. We know how to do the first one. We certainly have been doing this. If name is equal to Bob, then do something. That's dumb, but that expresses it. That's form one of the if statements. Or if else. If name is equal to Bob, print hi, else print go away. We're really rude here. And then the third one would be if else if. If name is equal to Bob, cout hi. Else if name is equal to Joe. We like Joe, but we don't like Joe quite as much, so we're going to print a cooler greeting. Hello, period. Have you ever noticed that if somebody sends you a text and they put a period at the end of it, it sounds more serious? Like, you know, your wife or boyfriend or somebody says, you know, come home. But if they say come home, period, you go, uh-oh. Anyways, here we go. And then if their name is neither Bob nor Joe, we will tell them to go away. Those are our three different cases: if else's, and if else ifs. Some languages actually have a separate keyword for that. I think Visual Basic does. I know that Python does. It has the keyword elif. So that is not a bad little snippet of code to have you memorize. How to test if a number is even. If x%2 is equal to 0, that tests it if it's even. Cout, it's even. Else, cout, it's odd. How would you check to see if something was evenly divisible by 100? What kind of if statement could check to see if it was evenly divisible by 100? Well, whenever you hear the word evenly divisible by, think modulus. If x% 100 is equal to 0, then cout, it's a multiple of 100. Else, cout, not a multiple of 100. Does that make sense? If you wanted to see if something was evenly divisible by 10, you just modulus by 10 and compare it against 0. Nested if statements. You can nest if statements by putting them inside each other, kind of like one of those Russian dolls where you have an itty-bitty doll at the center and you have a larger one and you have a larger one and you have a larger one. Those are nested. That could be something like this. If money is greater than 0, we're going to reverse the logic of this. If our hunger is greater than 0, then if our money is also greater than 0, we'll go out and eat. We could write this another way. If hunger is greater than 0, and we could do if number of friends with money is greater than 0. Go out to eat.
You're not paying for your friends to eat.
No, they're going to pay you away. Yeah, yeah. These are silly examples, obviously. But a nested if is when you put one if inside the body of another if. Quite often, a nested if could be replaced with an and. We could rewrite this one like this. If hunger is greater than 0 and money is greater than 0, go out to eat. Else stay home or whatever. So nested ifs can sometimes be replaced with ands. Cascading ifs, which is when you have if, else if, else if. No, never mind. I'm not going to go there. Here's the syntax. If employed is equal to yes, yes, then come in here. If you're a recent grad, yes, then you get the bonus. If you're not employed, or if you are employed but you're not a recent grad, you don't get the special offer. So that's an example of a nested if. Probably better than the one that I had here. If employed is equal to yes, or maybe it's a Boolean variable. If employed is equal to true, if recent grad is equal to true, then we'll print you qualify for the bonus. You qualify for the special offer. Again, we could replace this just with an and. We could say if employed equals true and recent grad is equal to true. And when you're comparing against a Boolean variable, it's not necessary to say equal equal true. You could rewrite this and it would be just as valid and look less amateurish if you did this, if you took that part out. Like that.
Because the default is true?
Pardon me?
Because the default is true? Or
It's because if you compare a Boolean variable to true, then that will return a true, if it is true. So saying employed is equal to true is the exact same thing as just saying if employed.
when you initialize it, though, what is the default? Is it true or false?
Oh,
It's true.
they have no default value unless they are part of a class, in which case they get initialized to false. So when I do this, if I do Boolean employed, unless I've actually set that somewhere, it's at some indeterminate value. We don't really know whether it's true or false. We're using an uninitialized variable. So saying if A is equal to true is the same thing as saying if A. If you're checking to see if something is false, if A is equal to false, that's the same thing as if not A. So we could say if not employed or not recent grad, anyways. We have gone just about far enough on this. Nested if statements. Use proper indentation just because it makes it easier to read your code. And if you mess up your indentation, then if you go into the edit menu and choose edit special format, then sometimes it'll fix your indentation for you. Here's an example of nested ifs that could not be replaced with the and. And the reason it can't be is that they want 3 different things to happen, not just 2. The 3 things is if both cases are true, we say you qualify. But in other cases, if you're not a recent grad but you are employed, we want to print out a special message that says you must have graduated from college in the last 2 years. And then if they're not employed, we want to print you must be employed to qualify. Now there's more than one way you could write this kind of thing, but this is showing a nested if. The outer if is the employee check, and if they're not employed, then we print you must be employed. But inside the code block for that if is another if, and that one is based on the recent grad variable. And if recent grad is true or is equal to yes, we print you qualify for the special interest rate, else we print you're not a recent grad. All right, and we've already talked about if, else, if. That's a good place to stop. My little marker to myself. Okay, so what is a CPP file? That's the source code file containing C++ code. What is an executable file? At least it's an exe on Windows. On a Mac, it's an application or whatever. That's the resulting file after the compiler runs. That can be run on the computer. So even though we don't see it, after we click the make button or whatever, it'll go and make an executable. So how is an executable made? I think I'm going to just delete this question. But anyways, how is an exe made? Compiler runs on the CPP file to make the executable. It's actually more complicated than that. A linker then comes and links the results of the compiler to make an executable. And that's kind of why I'm wishing that I don't have this question. I will delete it. But if I forget to delete it, just remember, the CPP is the one that contains the source code, and the executable is the program that runs on the computer. Know the difference between if you have a 9 in single quotes, a 9 in double quotes, a 9 without a point, a 9 with a decimal point, and you have the word true or false. And then you have the following possibilities: int or long, float or double, string, character, and Boolean. Which of these is which? What is that one inside the single quotes? That's a character. What is that one? That's a string. What is that one? It's an int or a long. What's that one? It's a float or a double. Now I actually don't get sneaky, so that would be a double. That would be the int. Three plus 4 times 5. What does that equal? That equals 23. Why does it not equal 7 times 5? 35. Multiplication happens first because of PEMDAS. Parentheses, multiplication, division, addition, subtraction, and just remember that modulus is at the same level as multiplication and division. So you have parentheses, you have multiplication, modulus, and division at second tier, and you have addition and subtraction as the third tier. Five percent 2, what does that evaluate to? Yep, 1. 3 plus POW, 3 comma 2. What does that evaluate to? Well, what does this do? It raises 3 to the power of 2. So 3 times 3 is 9, plus another 3 is 12. What if you have something like this? A is equal to 10. B is equal to 20. C's equal to A plus B. And then C plus plus. So C is equal to A plus B. What does C equal then? It equals 30. And then we tack one more on. And so after all that's done, C is equal to 31. We have talked that C is equal to C plus 1 is the same as C plus equals 1 is the same as that, right? All three of those do the same thing. You know what curly braces do. These are for blocks of code. You know what that is. That's modulus. You know what parentheses do. Enclose or group parts of an expression. You know what that does. What is the pound sign used for? Yeah, that is our preprocessor symbol. Preprocessor command, directive. And one that we use most often is pound sign include. What's that do? Send output to a stream, like cout. What's that do? Read input from a stream. And this is matching, so it's not like I'm going to make you write the words send output to a stream. But you know, you've used this before. So what does plus plus do? Yeah, that's increment, add 1. What do 2 slashes do? Yep, that's a comment. Give me some examples of keywords. Keywords are the things that define the language. While, if, double, int, using, namespace. All of those are keywords. How about identifiers? What are identifiers? Identifiers are variable names or function names, and later on class names and method names. So those could be things like age, height, weight, number of angles, things like that. Or what are operators? Operators are symbols. We've used a lot of operators so far. Like what? Give me a few examples. We use some more today, but they won't be on the exam. What are our arithmetic operators, for example? Plus, minus, multiplication, division. Equal is also an operator. It's the assignment operator. Equal is an operator. It's the equality operator. So identifiers are the variable names or function names, things like age. You know. So if you have this, a is equal to 10, and then later on you do a is equal to 3. When a new value is placed under the variable, what happens to the old value? What happened to that 10? Yeah, it's gone. Gone for good. It's overridden. It's replaced. Destroyed.
Gone forever.
Gone for good. All right. This is chapter 4 stuff, so I'm going to have to remove that one. Know how to write a few snippets of code that if I ask you to do this, declare a variable named height that is a double. Display the message, what is your height? Read from input into the height variable. And display the message, your height is, followed by the height variable. And then if you had 4 lines in which to do that, you could do that, right? How do we do that top one? How do we declare a variable named height that is a double? Double space height. Now how do we display that message? I'm losing my voice. We know how to display a message. Somebody tell me.
You see out.
Yeah, see out. Now how do we read in to that height variable? Yep, CIN. And then lastly, how do we display that message? We use see out again. Your height is height. I wouldn't count you wrong if you didn't leave off the ENDL, but okay. What does it mean to declare a variable? That means you give it a type and you give it a name. If you don't have a type and a name, you haven't declared the variable. Is C++ case sensitive? If I have a variable called height and then later on I do height with a capital H, is that a syntax error or is that good?
Syntax error.
That's a syntax error. C++ is case sensitive.
Are you adding 1 to the C?
Pardon me?
Nothing.
Yeah, the reason for the name is it's a better version of C. Okay, we can't do that one. Need to remove that one. What is a prototype? A prototype is a function header with no body. For example, on our random function, we had a prototype for, the get random value. But you could do something like this. If we have main, and then we want to print something, void print, cout, hello, and we want to call the print function from inside main, we have to prototype it. So we have to declare the function, but then we just use a semicolon. We don't give it a body. And that tells the code, tells the compiler, oh, by the way, even though we don't have a print function defined yet, there'll be one coming up. So it's okay for the programmer to use it. I don't think we've only done that once. I may remove the question about what a prototype is. But now you know, that's the prototype. Prototype is a function header without a body. Why is it used? To let the compiler know how the function is called and what it returns. When we call this function, we don't pass in any data. When it returns, it's not going to return anything because it's declared as void. However, that question is going to go bye-bye. We've gone over that. We've gone over that. We know how to do that. Alrighty, that's about it. So review your first quizzes, first two quizzes. I'm not going to save these notes and upload them, but if you want, you can watch the last 10 minutes of the class lecture and get a refresher on the rest of it. So I will see y'all on Thursday.
Have a good night.
You too. I am saving the notes, but I'm not saving this stuff that I typed at the very end. But you can watch the video again if you need to. Okay, so you can take notes from that.